Hello everyone, my name is Ali Ibrahimi and today I'm going to present our paper titled Comparing Visual Attention with Leading and Following Visual Humans in a Collaborative Perception Action Task in VR. This paper presents a within subject study to investigate the effects of leading and following behaviors on user visual attention when collaborating with the virtual humans during performing transportation tasks in immersive virtual environments. This study was motivated since remote embodied collaboration in shared virtual environments is becoming increasingly popular. In this study, participants are tasked to carry an object from an origin point to a target destination point with the help of a virtual character. During the experiment, participants wore a head-mounted display and performed real walking in a room. Here's a short
Move the
video
table to the
of
red
the
marker on the ground.
visual avatar
Later you should grab the green
leading
handle,
the,
and
the,
I
the
will grab the
user to
blue one.
perform a task in a
Please
living
grab the
room
green handle.
environment.
Lift up. Move backward. Move backward. Move backward. Move to your right. Move to your right. Move downward. Lower. The table is close enough to the goal. Please release the handle. The collaborative task is finished.
During this task, we collected users' visual interest to measure how their visual attention interest changes between follower and leader roles in object transportation tasks. But why it is important? In joint motor tasks, users evaluate the actions and infer the intentions of their co-actors. Humans try to predict the actions to anticipate the co-actor behaviors and coordinate their own movements. Also, previous experiments helped for decoding the other person's sensory motor intentions. An important topic is what is known as action observation. This concept is used in the field of human robotic interaction and is concerned about predicting the intent of the robot while performing the physical task. Action observation is useful for detecting mistakes or error during collaborative physical actions or performances. Action observations in joint tasks help us to plan our movements. We observe our collaborators' behaviors and we react based on this. We coordinate our movement with the movement of the other person. Studies report that humans visually attend more to stimuli that they find more interesting or relevant. Examining the head direction was helpful in estimating the gaze location in head coordination task. Additionally, in human visual human interaction, it was found that participants' visual attention varied depending on the task in that environment. During mutual coordination, people who are interacting with each other share a common goal involving physical and mental system. Also, they share information verbally and non-verbally. So for this study, we created the following research question related to visual attention during collaborative tasks with virtual human. What were the most visually salient objects in the leader condition? What were the most visually salient objects in the follower condition? And to what extent do visual attention behaviors of user differ between the leader and the follower condition? In this system, user performed real walking and transported virtual objects with virtual human. We collected the user visual interest by projecting a ray from head-mounted display. We detected the collision from this ray to the geometric in the environment. We collected visual attention intersections with a virtual human, the goal position, the user handles, the obstacles such as furniture. We also focus on virtual human's head, chest to determine the proximity with the virtual human to the target object. Finally, we measured the bottom part of the body to determine if virtual human was moving. We map user hand position to the pair of virtual hands. The user and virtual human hands determine the orientation and center position of the target object. This experiment included a living room environment with eight tasks involving moving a dining table and a TV. Also, a warehouse scenario demanded moving boxes of different sizes and different shelf positions with a total of 12 tasks. There were two conditions, namely leader virtual human and follower virtual human. The leader gave instruction to the follower to perform actions. In the leader virtual human condition, the user played the leader role while they played the follower role in the follower virtual human. We collected data from 17 participants where they completed a total of 40 tasks. This graph shows the overall experiment timeline. It starts from top left and it goes, all the participants go through the exact same procedure to complete the experiment. At the beginning of this presentation, I show you a demo of the living room scenario. This is a warehouse
Later
scenario.
you should grab the green handle, and I will grab the blue one. Please grab the green handle. Lift up. Move to your left. Bring your hands back. Move to your left. To your left. Next, we need to adjust our hands near the corners that are closer to back handle. Then we can push the object into the shelf. Now I will show you how to adjust. Please focus on my actions. Now it's your turn. Please take my actions as reference and adjust your hands near the corner at your side. Finally, let's push the object into the shelf to finish the task. Please gently lower the object. The box is close enough to the goal. Please release the handle. The collaborative task is finished.
Result reveals significant differences in the user visual attention behavior between the follower and leader conditions during the transportation tasks. We conducted two-tailed per t-test for comparing the objective measures of participants between leader and follower condition. We collected task time, attention duration, attention allocation, attention transition from the object to the virtual humans. There was no differences on task time between the follower and leader conditions. Regarding attention duration, there were significant differences between the follower and leader condition in the virtual human head, chest, and bottom, also to the task object, to the left and right hand and handles. Regarding attention allocation, there were differences between leader and follower condition on attention allocation measured to the virtual human's head and chest, also to the task object, obstacles, left and right hands, and handle. Additionally, there were differences in attention transition between leader and follower condition on the agent's head, chest, task object, goal, obstacles, left and right hands, and user handle. We also asked qualitative questions to the participants. To the question, how helpful is your partner's help in accomplishing the task, participants in leader condition said that was easy to follow. Gaze contact suggested me to perform suitable actions. It was too strict, not smooth. Also, participants in the follower condition stated that the experiment was agile, can improve teamwork experience, and does not react until I gave him an order. So now going back to the research question that we had at the beginning, we wanted to answer to the question, what were the most visually salient objects in the leader condition? Overall, results show that user in the leader condition gazed more at the task object, the user left and right hands, and the handles. Our second research question was, what were the most visually salient objects in the follower condition? And in that, user gazed more at the virtual human's head and chest. And finally, wanted to know to what extent do visual attention behavior of user differ between leader and follower condition. And for that, user in the leader condition focus more on the task-related objects of interest, such as handles and target objects. On the other hand, in the follower condition, user gaze more at the agent's head and chest. So, in this work, we investigated the user attention behavior while user and virtual human transported target objects in immersive environments. Our results show that visual attention was stronger to virtual humans in the follower than in later condition, while visual attention to the target object and user handles, obstacles, and their hands was stronger in leader condition than in follower conditions. This work contributes to the novel design of virtual humans in collaborative tasks involved with user motor skills. Future work will be focused on analyzing the eye movement activities of participants more granularly using gaze instead of head direction. Thank you.